the configuration? Have you seen
Sorry,
the configuration?
even the topology, something. I didn't save. That's why I lost everything today morning.
But I think
But
your lab is working fine, right?
yes, it's working fine. But I have some message that I cannot connect, blah blah blah. But I think it's not a big issue. Let me save it with share it share with you by WhatsApp.
Your voice is not clear, UNC. Can you repeat again?
I say that I'm receiving some message.
Hmm.
Then I think I will. I'm going to share with you by WhatsApp.
Okay. I don't have my phone right now.
Uh, you don't. Are you there for your phone now?
Wait.
Okay, no problem. We can start.
Okay.
We can start this session.
Okay. Let's start our discussion now. Have
Yeah.
you received last session videos?
No, you didn't send. Oh yes, yesterday
Yes, yesterday's session.
I didn't receive.
Okay, no problem. I will share today, okay, after the session. Now let's focus on our topic. So we complete till now authentication concept, and today we can start root summarization. Root summarization. What is root summarization concept? In root summarization concept, you can minimize the size of the routing table. You can minimize the size of the routing table. This is our topic, root summarization, root summarization. So let's create a design. Let's create a scenario. For example, I have multiple routers into this design. I have multiple routers. These are routers, not desktop machine. These are routers. And we have a connectivity. So we have multiple routers here. Okay, these are the routers. And into this design, this R2, for example, this R2 is receiving multiple routes information from this side. This side, he has multiple routers. He has connectivity with multiple routers. This R2 is receiving a lots of route information. Okay, for example, R2 is receiving 10.1.12.0/24, 10.1.13.0/24, 10.1.14.0/24, and so on, approx 100 network information. R2 is receiving 100 network information. Now R3 is also receiving some route information from this side. For example, R3 is receiving 10.2.12.0/24, 10.2.13.0, 10.2.14.0, and so on, approx 100 network information. Now R4 is receiving 10.3.12.0/24, 10.3.13.0/24, approx 100 routes R4 is receiving. So when R2 is receiving 100 network information, when R2 is receiving, R2 is sharing these route information with R1, 100 network information. Now R3 is sending 100 network information to R1. Same R4 sending 100 network information to R1. Now, if you are managing R1 router, for example, R1 router,
Mhm.
for example, if you go with show IP route command to verify your routing table information. So now in your routing table, you are receiving 300 networks information,
Appointments, yes,
right? And
yes.
if you remember routing table entry, each network information will store in separate line. It means you have approx 300 lines in your routing table. 300 lines in your routing table. This is the issue. This is the issue. With route summarization, protocols can summarize route. Protocols can summarize route. Protocols can minimize the size of the routing table. And if you talk about route summarization concept, so if you remember, wait, actually we have two type of summarization concept, auto summarization and manual summarization.
Mhm.
Manual summarization. Auto summarization, RIP and EIGRP protocol. RIP and EIGRP protocol, they support auto summarization by default. By default. No need to configure. By default, they do auto summarization. By default. It means R2, if you are using RIP protocol or EIGRP protocol into this design, then this
Okay.
R2 is trying to minimize the size of the routing table. So R2 will send only one entry. R2, R3, and R4, they will minimize the size of the routing table because RIP and EIGRP, they do auto summarization by default. So R2 will summarize 100 network information in a single line and then send to the R1. The
Mhm.
problem with the auto summarization is what? It's a class full summarization. Class full summarization. This is the issue. It means R2 will summarize these network information in a single line and it will send what? It will send 10.0.0.0/8. It means if IP or if network is a part of class A IP, router will or protocol will summarize this route information with /8. If IP is a part of class B, it will summarize it with /16. If it's a part of class C, it will summarize with /24. So you can see we have E
Okay.
class IP, E class IP, right? This is class A IP.
Yes.
Now R2 is sending single line entry. R2 is sending single line entry 10.0.0.0/8. It will minimize the size of the routing table in a single line. But the problem is it's a class full summarization. Okay, if you are managing this R1 router, if you check your routing table, okay, and if you have an entry which start with 10, it means you can say you have all the routes. You have all the routes which start with 10, but it is not true. It's not true, okay, because you have only 100
Mm.
network information, right? You will see.
Yes.
In routing table, what you are getting, you are getting routes which start with 10. But no, here what you have only 100 network information. R3 is trying to minimize the size of the routing table. It will minimize in a single line and it will send what? 10.0.0.0/8. Same R4. R4 is sending what? 10.0.0.0/8.
Yeah.
This is the issue with class full summarization. That's why we are looking
Mhm.
for manual summarization.
Manual.
In manual summarization concept, administrator, router administrator will find the summary address. Router administrator will find first summary address of these routes. Will try to find summary address of these routes. And these summary address information administrator can use in protocol. How to use in a protocol, I will show you in lab. But let's talk about
Mm.
how to find summary address of network. Summary address, because we are looking for classless summarization. We are looking for manual summarization. Manual summarization. Let's talk about how to find summary address. How to run summary address in protocol, we'll discuss in practical. But how to find summary address, wait. So let's go with the scenario. I have IP address 10.1.12.0/24, 10.1.13.0/24, 14.0, 15.0, 16.0, 17.0, 18.0. So we have approx 1, 2, 3, 4, 5, 5, 6, 7. We have approx 7 routes slash 24. So a router is receiving 7 network information. And
Mm.
this router administrator is looking for manual summarization. Okay, he is looking for manual summarization. So for manual summarization, administrator will find summary address of these networks. Summary address. What is the use of summary address? We'll discuss in protocol. But right now, how to find a summary address? Let's let's go with this question. How to find summary address of these networks? So if you want to find summary address of these network, you can take first network and last network in this range. First network and last. And you can also verify. You will see this is contiguous network, right? This is contiguous
Yes.
network. If you, for example, if you are receiving some root information like this, for example, 10.1.10.1.12.0/24, 172.16.10.10/24, 10.0, and 192.168.10.0/24. If you are receiving roots like this, you cannot minimize, you cannot summarize these roots, okay? So remember, always you can only summarize contiguous network, okay? Contiguous network.
Mm-hmm.
So these are what contiguous network. Same, see, 10, 10, contiguous network. So now I'm looking
Mm.
for summary address of this network. What you can do, this is the first step. You can take first network and last network. So first network is 10.1.12.0. Last network is
Mm.
10.1.18.0.
8. 18.
Now you
Yes.
can see these first two octet. These first two octet, they are what? They are fixed. They are not changed. Yes, we have
Yes.
changes. We have changes in third octet, right? We have
Yes.
changes in third octet. So here we can change this third octet into binary. Into binary. So I'm trying to change 12 into binary. So 128 no, 64 no, 32 no, 16 no, 8, wait. 128 no, 64 no, 32 no, 16 no, 8, 4, 2, 1. You see clear? Decimal to
Mm.
binary conversion. Now 18, 128 no, 64 no, 32 no, 16, 8, 4, 2, 1. Clear?
Yeah.
Remember binary to decimal and decimal to binary conversion in Ccnp training? I'm trying to convert
Uh,
into binary, okay?
okay.
This is binary value, yes. Now 0, yes, 0 I'm changing into binary, 0, 0, 0, 0, 0, 0, 0, 0, and 0, 0, 0, 0, 0, 0, 0, 0. Now, once you change your decimal value into binary, what is the next step? Your next step, match bit, match bit. And here, if 0 match with 0, you will get number 0. If 1 match with 1, you will get number. So what I'm trying to do, I'm trying to match here bit, and you will always match from this side. Always match from this side. So you can see 0, 0 match, no problem. 0, 0 match, no problem. 0, 0 match, no problem. But now here you can see it's not match. It's not match. So now here you can draw a imaginary line. Imaginary line. Now you can see when 0, 0 match, you will get a number what? 0. So here I have a 0,
Mhm.
then 0, then 0. And here it's don't match, right? You can see
Yes, not
when it's
much.
don't match, you don't care anything. You can just type 0, 0, 0. Just type 0, 0, 0, 0, 0, and here 0, 0, 0, 0, 0, 0, 0, 0. Now you can change this binary value, this octet into decimal, so 0, and this is what? 0, and what we have? 10 dot 1 dot. So 10 dot 1 dot 0 dot 0. This is what? Summary address. And what is slash value? What is slash value? So you can see here, this is what? This is 8-bit value. This is 8-bit value. This is
Eight.
what?
Yes.
8-bit value. So 8 and 8, 16. And we match 3 bits. We match 3 bits. So 8 and plus 8, 16 and plus 3. What? 19. So here we have what? 19 slash 19. This is your summary
Okay.
address. This is your summary address. You cannot type like this format slash 19. So you can go with this format 10 dot 1 dot 0 dot 0. And what is 19? 19 means it means 255 dot 255 dot 224 dot 0. This is your summary address. Clear this question? You can see.
Yeah. uh, Yes, it's clear. I think we can take another example.
Yes, see, I'm giving one question. Okay, you can try first. Okay, if you face any issue, I can help you. Okay, I'm giving one question. You can try first. So I'm giving one question. 7 dot 7 dot 0 dot 1, 7 dot 7 dot 1 dot 1, 7 dot 7 dot 2 dot 1, 3 dot 1, 4 dot 1, 5 dot 1, 6 dot 1, 7 dot 1 slash 24. Please try to find summary address of these networks. Okay, you can see.
Okay.
I'm giving you 10
First,
minutes. Give you 10 minutes. Please take paper and pen. Okay. And I'm giving 10 minutes. Okay.
okay, you say 7.7 dot
You have one
7.
example. You have one example here. This can help you to solve this question.
Okay,
You can
this
try.
is
Okay. You can take 10 minutes. No problem.
4. And I take the last one. Mhm. 7, 7, 1, 7, Okay. Mm, okay. This is 0, 0. Mm, element of mm, Dois, isso é zero, um, zero, isso é zero, só, x, 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 então, zero, zero, ok. Oh, sim, o matching, zero, 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 tá, matching, but, but, minha mãe, hum, 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 da, hum, da, hum, zero, up, acho não, hum, I have one issue, no? Hello, dear.
Hello, UNC. Can you hear me, dear?
Yes.
Yes.
I find the IP, but for this case, I have one issue to find the subnet mask.
Can I try this question? Can I try this question? UNC?
Yes, no
Then you
problem.
can try the next one. Next one I will give you. Wait. So what is the next step? What you can do? You can take first network, UNC, right?
First network and the last one.
First network and last network. What is first network?
First network is 7.7.0.1.
0.1. And what is last network? 7.7.7.1, right?
Dot one, yeah.
Okay, okay. So let's try to solve this question. Then I will give you one more question to for some reactors. Okay, so first network is 7.7.0.1. Last network is 7.7.7. Now
Yes.
these two octet are fixed. Now we can see here we have changes in third octet. Let's change this 0 into binary. So 0 0 0 0 0 0 0 0 and 1
Yeah.
0 0 0 0 0 0 0 1. Now 7, so we can change 7, 128 no, 64 no, 32 no, 16 no, 8 no, 4 4 2 1. Then 0 0 0 0 0 0 0 1. Now we can match our bit. So 0 0 match, 0 0 match, 0 0 match, and 0 0 match. Here we have it's don't match. So now we can draw a imaginary line here. Now, if you match 0 with 0, you will get number 0, then 0, then 0, then 0, then 0. And from here we don't match. So you don't care anything. Just type 0 0
Yes.
0 0 0 0 0 0 0 0 0 0 0. If it is match here,
Yes.
don't care, okay? Because from here it's not match, from here it's not match, so you will type 0 0 0 0. Now if you change this binary into decimal, so 0, this binary into decimal 0, and what we have 7 dot 7 dot
Mm. 0.
7 dot
Yeah.
7
This
dot
one
0
I
dot 0.
found.
Now, so what is slash value? So this is what? This is 8-bit value. Wait, this is 8-bit value. Okay, this is what? 8-bit value. So 8 and 8 16. And we match what? 5-bit. So 8 and 8 is 16 and 5, 21 slash 21. This is what? Summary address. This is summary address.
Uh, hmm.
Now,
That's from my side.
now,
Okay.
now 7 dot 7 dot 0 dot 0. What is 21 means? What is mask? 255 dot
Mm.
255 and 5-bit on. So 248 dot 0.
Uh,
You can see clear?
I think I found where is the problem. My problem is this bit conversation con converter to convert this the IP this IP to bit 000. Yeah.
Is it clear now for you?
Yeah, but it's clear. But I need to learn again
Okay, I'm giving
this
one question. I'm giving
conversion.
one question. You can try. Okay. I'm giving one question. You can try. Take your time, no problem. Now, this is the question. Try to find the summary address of this network. This network. You can take first network and what? Last network.
Last network. A second there.
172.16.25.0 first network. 172.16.29.0/24. Now you can try.
But my problem is the conversion only
Okay.
from number to byte to bit. This is the main issue from
If
my
you
side.
remember binary to decimal or decimal to binary, so this can help you.
Yes, this one I think I need the help. But the logic I understand.
Yes.
I understand the logic of summary, but this convert to convert this, by example, this 125,
Yes.
how
Just
to
try to solve
convert
this
it.
question, okay? This question, okay? Just try to solve. You will see.
Okay,
Yes.
okay.
Here's examples. Try to solve.
Mm. Mm. Submit this video. Okay. And here is matching. Match. Match. All matching. That means uh, mm, 1, 2, 3, 4, 5, 6, 7, 8. That means it can this one is 8. Okay. Okay. Let me find um, this is great. Okay. And that address will be 3, 1, 7, 7, 7, 7, iPhone. Okay. Hello there.
Yes, GNC.
The summary address will be 172.16.0.0 and slash 24. That means 255.255.255.0.
Okay, wait. So you take first network, right? 172.16.24.0 and 172.16.29.0, right? This is your
Yes.
network. And what is your answer? 172.16.0.0
16.0.0
slash
slash 24.
slash 24. Okay, no problem. Let's try for this question. Let's try. So we can change 24 into binary. So 128 no, 64 no, 32 no, 16, 8, 4, 2, 1. 4 to 1. Now 0, 0, 0, 0, 0, 0, 0, 0. Now 29. So 128 no, 64 no, 32 no, 16, 8, 16, 8 is 24, 4, 2, 1. 0, 0, 0, 0, 0. Is it correct? You can see
I didn't find this on my
29,
side this time.
29 into binary. 29 into binary. 1, 2, 4, 8, 16. 16 and 8, 24. 24 plus 4, 28 and 1, 29. So now you can match your bit. 0, 0, match. Yes. 0, 0, match. 0, 0, match. 1, 1, match. 1, 1, match. And here it's don't match.
It's not
So now
much.
you can draw a line here. And now when 0, 0 match, you can get, well, 0, 0, 0 here, 1, 1. And now all 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Now you can,
That's the issue.
yes, now you can change. Now you can change into decimal. You can change into decimal 1, 2. If you remember binary to decimal question, 1, 2, 4, 8, 16, 32, 64, 128. So if you
Mm.
change this binary into decimal, you will get 24 here. And this is dot 0. And now 172 dot 16 dot 24 dot 0. And what is slash value? What is slash value? So this is 8-bit value.
21.
This is 8-bit
2-bit
value.
21.
And you match 5-bit, right?
5-bit.
So
Yeah.
8 and
21.
8, 16 and 5, 20.
21.
This is what your summary address.
I have issues for this convert to convert the byte.
172.16.24.0. It's a simple, okay, but if you remember binary to decimal and decimal to binary, okay, this is your summary address. Clear now, my point? Juvency, clear now? Juvency, can you hear me, dear?
Yes, I can hear you now.
Okay, now I just disconnected my modem, but I hope you can hear me, right?
Yes, I can hear you.
So this is our question: how to find a summary address of network. Now we can go for practical implementation, but we can do practical tomorrow, Juvency, okay? Because we cannot complete today. Okay, dear.
Okay.
So we can complete our lab. And what is our lab? We will discuss root summarization concept in RIP protocol, in EIGRP protocol, and in OSPF. Yes, you can discuss root summarization in BGP, but it's a separate concept. Okay. When you have an idea about BGP protocol, we can discuss root summarization. But right now, you are only familiar with IGP protocol, right? So we can discuss
Yes.
how to go with root summarization practical in these protocols. Let's do our lab tomorrow. Okay, Juvency?
Okay.
Please do practice there, okay? I'm sharing last session videos and today's session videos in 30 minutes. Okay?
I have one question. The root summarization. Did you share with me the document?
This slide, you're
Yes,
talking about
it's
this slide or video?
no slides.
I'm sharing slide. Wait, give me 2 minutes. I'm sharing slide.
Okay. I need to understand this one very, very well. Very important. Many IT have I can say this issue. First is to find
Yes.
this summarization address, IP address, and the second one to make this calculation.
Please check Zoom chat window. I shared with you some slides.
Sorry,
I shared with you some slides on Zoom chat window. Wait.
on this chat, on this chat, right?
Yes, Zoom chat. Yes. It's uploading. Wait.
Okay. Yes, I. Oh. Mm. I can open this doc.
Now you can download. Have you received the slides in Zoom chat?
Yes, I'm going to download. Mhm. Okay. If we stop the session, are we not able to download, right?
Yes, yes. No problem. I'm sharing on mail. Okay, no problem, Juvency. Okay, I'm sharing on
No,
mail.
I already uh, took some of them. It's very speed from here. It's very speed. I think 4 or 5 remaining. VTP, image filtering. I think it's all. Mm, that's all. It's okay.
Okay, dear.
Yes, 1, 2, 3, 4, 5, 6, 7, 8. 8, you shared to me, right?
Yes, yes,
8 documents. BGP,
yes.
I didn't say.
OSPF,
Mm,
protocol authentication, route filtering, span, STP, summarization, switching, BTP, BGP, and EIGRP.
okay. Yeah. Let me do the last check. This one existing. SPF also existing. And switching PT existing already. Okay. I think I get all. It's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3,
One,
4,
two, three, four, five,
5,
six,
6,
seven, eight, nine. Yes, 10 slides. 10, no, 10, 11
10
slides.
slides.
11.
11?
Yes. One, two,
That
three,
means
five,
I lost one of them.
6, 7, 8, 9. Yes, 10, 10. Yes, 10. You can see 10, 10 slides.
Okay. 10, right?
Okay, let's connect tomorrow.
Okay.
Same time, Juvency. Okay.
Okay.
Bye,
I
dear.
will.
Bye. Bye, dear.
Hi. Bye.
Bye.
Bye. Thank you.